Hello, my name is Mridhula, and I am working with Dr. Amy Landis to optimize food waste management options and to see if there's any possibility for energy or nutrient recovery at the Colorado School of Mines. This is my presentation for the Mines Undergraduate Research Program. So just a little introduction into food waste. Food waste is a problem in the United States when it really shouldn't be. There are large amounts of food waste that is being sent to landfills, while at the same time, food insecurity is a huge problem. About 40% of the food produced is wasted in the US, and finding solutions for it not only helps reduce waste and help with insecurity, but also helps the environment. The production of food uses a lot of resources like water, land, and nutrients, and contributes to environmental impacts like climate change and eutrophication. So producing food in excess is an unnecessary impact on the environment. About 10.5% of US households, which is about 13.7 million households, were food insecure in 2019, and we'll likely see an increase in this number in 2020 because of the pandemic. The goal of this project is to decide the best way to utilize food waste on the Mines campus, whether that's through composting or converting it to energy. Another goal of the project is to determine if there is food on campus that is still good to be donated, but due to lack of awareness around resources like Blaster's Basket, the food becomes wasted. For this project, we focused on collecting data for the waste produced by Mines Market and the periodic table, as they're the main sources to get food on campus. Republic Services is the waste company used at Mines, and there are compactors for each building, and all of them have different rates and pickup times. Currently, Mines sends all its all its trash to landfill, and Mines has composted on site a few years ago, but they stopped the program because of complaints of smell. The landfill which the trash is transported to is about 8.8 miles from campus. Since Mines Market and Periodic Table are not lone standing, we had to look at the data for Elm Hall and the Student Center. The data collected here is not just for food waste, but for trash overall in the building. In order to collect data for just the food waste, an audit would have to be completed, where we would go to these buildings and we would take the food waste from each building, collect it, weigh it, and categorize it. The data collected in this audit is from the trash and recycling bills. For Elm, for each pickup, up to 1 ton is flat rate, but then if it weighs above a ton, each additional ton will have extra fees associated with it. And if you look on the slide, this is the data that we got for 2019. And for this year, I was able to get the tons average per month for both areas. And this is the data for 2020. Unfortunately for this one, I was not able to obtain the tons of waste, but I was able to obtain the costs, and the pickups and the compactors, they all stay the same. But in 2020, the price per load per pickup increased for the Student Center. Now moving on to energy audit. We're looking at energy use and costs to see if there's an opportunity to turn food waste to energy on site. Xcel Energy is the energy provider and charges different rates for different buildings on campus. There are other sources of energy on campus, one being a solar panel installed in the parking garage in mid-2020, but this is a very small source of energy. Similar to food waste audit, the data for energy use was obtained via the Xcel Energy bills. The overall energy consumption in 2019 was about 33 million kilowatt hours, which costed us about $2,700,000. In 2020, the cost was about $2,500,000, and we used 33,500,000 kilowatt hours of energy. When we're looking at Elm and the Student Center, where Mines Market and Periodic Table are located specifically, we can see that Xcel bills them as primary general buildings. There are other fees associated with This, other than the cost per kilowatt hour, they include service and facility, distribution demand per kilowatt, summer generation, and transmission demand per kilowatt. And as you can see, the on and the off peak rate is about the same amount. This is the energy data for both 2019 and 2020 for Elm Hall and the periodic table. Next, moving on to some waste management options. So these are the waste management options that we analyzed to see if there's any possibility for energy or nutrient recovery on campus, or even combat food insecurity on campus. The first one is anaerobic digestion. It's when bacteria breaks down organic matter, like food waste, without the presence of oxygen. This produces biogas and digestate. The biogas can be used for electricity and heating, while the digestate can be used as a fertilizer. Composting is when organic matter, again like food scraps or leaves, can be turned into fertilizer. And composting is done by speeding up the decomposition process by providing a nice environment for bacteria and fungus to help the materials decompose. Incineration is combustion of organic matter. The heat from combustion is used to heat water, and the steam from doing so is used to turn blades of a turbine generator, which produces electricity. And another one is an app. So Dr. Landis's research group has been working on an app that can connect community members to free food, which I'll talk in more detail about later. The other two options listed here are combinations. So instead of choosing just one option, we were thinking of combining them. Here's some pros and cons of each management option, and to fully get the pros and cons of it, I would have to complete the food waste audit, which unfortunately I was not able to do this year. But just general pros and cons from a literature reviews that I've done is, like I mentioned, for anaerobic digestion, the biogas can be used to lower heating bills. The residuals or the digestate can be used as fertilizers. But the cons of anaerobic digestion is that it has high upfront costs. So if there isn't enough waste to support the anaerobic digestion, it isn't really worth it, which is where the food waste audit comes in handy. If we look at landfill, there's no upfront cost because that's a system that is already set up at mines, and it's the most common method in the US. It's widely available. But the cons of that is that there's travel costs, there's low rate waste degradation, and pollution. So composting is relatively inexpensive and lowers waste spills, and we can also partner with the City of Golden to do so. But like I mentioned before, the problem with composting is that people can complain of the smell, and it can be labor intensive to take care of. And finally, with burning the food waste, we can get a lot of energy from it, and the volume of the waste that we will send to landfills can be reduced. But again, similar to anaerobic digestion, there are high upfront costs, and the ash from it can be toxic. Right. As I mentioned before, Dr. Landis's group is creating an app to combat food insecurity at mines. There are a lot of apps available to reduce food waste, but they don't have many of the parameters we decided are needed to be successful on college campuses. The app functions that we would like included in an app for a college campus are user-specific footprinting, ease of use, free to use, easy to post available food, and has single sign-on. And on this table, you can see it's just a comparison of a few of the more common food waste reduction apps out there, which is Olio. It's a popular food share app where users can post surplus food and others can request it to pick up, and it's usually for a reduced price. Too Good to Go and Last Call are only available in a small number of locations, and it's only for grocery stores and restaurants. Olio does have a school and university program, but it only is for the school cafeteria for something like Mines Market. So it would only be for Mines Market. It would not be applicable to events and things like that could go on at Mines. So as you can see from the table, the app that our group is trying to create will cover all those parameters. A component of this app, like I mentioned before, is user-specific footprinting. So users can see the impacts mitigated by getting food. And the app needs data on commonly available food on campus. So the main sources are from Sodexo. They do a lot of catering events. They do a lot of catered events on campus. And other ones are from campus events. So this could be club meetings, professional societies, and workshops. And that could be from a range of places. So far, I have been able to obtain data on the Sodexo catering, and here are the occurrences per week of each type of meal and the popular item associated with it. And as you can see in 2020, this is data from August of 2020 and fall semester. That number has reduced significantly. So some next steps and conclusions. For the user-specific data portion of the app, an LCA, which is a life cycle assessment, will be required to develop the environmental impact assessments of typical food items. Collecting data similar to what I did with Sodexo, but for outside food sources like Domino's or Jimmy John's and things like that. Unfortunately, no recommendations on the best food waste management options for mines can be made at this time, and this is because, as I mentioned before, I need to do a complete food waste audit at the periodic table and at Mines Market in order to recommend an option. Thank you so much for listening to my presentation.